Okay, we're going to do a second example with independent samples, but this time we're actually going to do a hypothesis test instead. So you're going to get one example of each, a confidence interval and a hypothesis test from the independents, and then we'll do another with the pairs. Okay, so we have random samples of students at 2 different community colleges were taken to see how many televisions were owned in each household. Each individual was randomly chosen independently from the others. Students were not chosen in pairs or groups, so they have went out of their way here to let us know that this is an independent situation, that students from one community college would have nothing to do with the students from another one. They were not chosen in paired relationships whatsoever. One of the schools is in a wealthy community called MC. 30 students were surveyed from there with a mean of 3.33 and a standard deviation of 1.49. And again, that's how many TVs on average are in a household in that community. The other school, OC, is in a less wealthy community. Of 30 students there, the mean was 3.7 and the standard deviation was 1.9. Test the hypothesis that the population means are not the same, and we're going to use our standard significance level. Okay, so first of all, we're definitely okay to proceed here because both samples were 30, which is bigger than 25. So both samples are good. We are very clear here that they're independent. We were told random and all those good things, so we are good to go here. Notice that in the sample, it actually is a little bit interesting here, maybe opposite of what you might expect. In the sample, the average number of TVs in the less wealthy community was actually higher than in the more wealthy community, but then they both had the exact same standard deviation. So that's a little bit interesting. Okay, first thing we want to do is write our hypotheses, our null and our alternative. So we're trying to test that they are not the same. So my null will be that they are the same. So something like the mu of this community is the same as the mu of this community. And the alternate is that they're not the same. So that this one is not equal to this one. That's how it's very natural to write these, because you're either testing, are they the same? Is one larger than the other? Things like that. So this is a really natural way for you to write it down. Just as a note, that is not how it's going to show up in StatCrunch though. In StatCrunch, they put, because when you're comparing two numbers, it's all on the difference. So they will write all of these as the subtraction version. So they will, instead of this one will be written as this minus this. And if I move this over here, then it's going to equal nothing on the right. If two numbers are the same, then you should be able to subtract them and get 0. And if two numbers are not the same, when you subtract them, you should not get 0. So this is the StatCrunch formatting. Even though when I write it down personally, I always write it the first way. So you can write it either way you want to for your own self, as long as you kind of understand that they're working kind of back and forth with those. Okay, we need to decide before we get going. We weren't given any direction here. Which one of these is going to be our sample 1 and our sample 2? And I'm just going to do it for simplicity's sake that the first one is going to be my sample 1, the first one that was listed, and that this one is going to be sample 2. For no rhyme or reason other than that was just the order it was given to me in. Okay, we are indeed going to use the alpha of 0.05, and we need to run a t-test. I need to remind myself that that's what I'm doing because this is all about means. Okay, so part 3 is to actually run that test and actually get our t and our p values. So we're going to need these numbers, the 30 sample sizes and the mean and the standard deviation of each one. We're going to need those in StatCrunch. So I'm going to pull this back up. So we're going to go into our 2 samples with summary. Sample 1 was MC. So that one had a mean of 3.33, standard deviation of 1.49, sample size of 30. The other OC had a sample mean of 3.7, standard deviation of 1.49, and sample size of 30. We're running a hypothesis test. And so again, notice that they're always going to do it with subtraction. So the first one is that I would subtract them and get 0. And the second one, because again, we were just testing, are they different? So it's actually fine as is. Sometimes you have to change this symbol here, but in this case, we were already doing the not equal to, so we're good. We should be able to just go ahead and compute and record our t-stat and our p-value. So I'm going to go back over here. The t was approximately negative 0.962, and the p-value was 0.3402. So again, what this looks like, if you kind of want to remind yourself, that t-value is how far out are we. So we were back at negative 0.962, and because it's two-sided, it means the positive version is also here, and the p-value is everything shaded beyond that. So we're not out very far on this one, which means we've got a lot shaded. Now we have to draw our conclusion. Draw your conclusion on your p-value. So since the p here came back greater than alpha, it came back bigger than this, we failed to reject the null. So what happened is we did not find enough evidence to say that there is any sort of difference in the mean TVs between these two communities. In the mean TVs per house in these communities.